to find the derivative of the function first before you plug in anything. So this is a function composition. So first I differentiate the outer and then the inner. And then I look at the table. F of 1 is 3. F prime of 1 is 4. And then I need to find G prime of 3, which is 9. 9 times 4. Is this okay, everyone?
Yes, thank you.
Okay, perfect. Next, anything?
Number 8.
Number 8, very good. I have not checked today. Is WebAssign done? Do you have any questions on WebAssign?
I have a question on WebAssign after this one.
Excellent.
Yeah,
Very good.
Are you recording this session or no?
Yes, of course.
Okay.
Yes.
All right.
What am I doing next? I'm sorry. It was number
8.
Number 8. Thank you. Okay, we had a similar problem in class together on this. So so we have u of x, which is f of x times g of x. So I have to find the function first, which is f prime times g of x plus f times g prime. And so we're asked to find the, okay, u prime of 1. So this is f prime of 1 times g of 1 plus f of 1 times g prime of 1. So can anyone give us g of 1 and f of 1? And then I will share my screen and determine the other ones with you, the derivatives. So can anyone give us these two so I can... How much is f of 1? Very good. And g of 1?
1.
Perfect. Now I'm going to share my screen. Where are you guys? Okay, I see you. To make sure it's clear how I determine f prime of 1. So f is this, and f prime of 1, so it's constant, right? It's a constant rate of change. It's a linear function. So I have this triangle that I'm looking at. It has a rise of 2 and a run of 4 and a run of 2. So 4 over 2 is 2. And that is f prime of 1. This time for g prime of 1 is this. Obviously, it's a negative slope because it's a linear function with a negative slope. And I would like to use also the corners of the grid. So I see a 4 and I see a 4. So this line has a slope of negative 4 over 4, which is 1. Of course, negative 1. So then this is negative 1. So then 2 minus 2 is 0. Good. So I'm ready for the WebAssign or anything else you would like to continue with.
What chapter is that problem?
I'm sorry, we are in chapter 3. So this is chapter 3. Are we talking about WebAssign?
Yeah, I had one. It was from section 3.5, implicit differentiation.
Yes, can you give it to me? Because it will take me a while to log in.
Yeah, the equation is 8x squared minus y squared equals 1. And then it wants y prime by implicit differentiation. And then after that, it wants you to solve explicitly for y and differentiate to get y prime in terms of x.
Okay. So implicit differentiation in this particular case is always the easiest. So when I differentiate this, I get 16x. When I differentiate this, is negative 2y dy over dx. And of course, this one is 0. So I move 16x to the other side, so I have dy over dx. which is both of them will be negative, so it's 16x over 2y. So the answer would be dy over dx equals 8x over y. So now in order to solve for y, then I have 8x squared minus 1 equals y squared. So if I want to differentiate, first I have to take the square root. And when I take the square root, this is not a function. I get plus or minus the square root of 8x squared minus 1. So these are two functions, not one. So I'm not sure why they are asking you to do that, but we can differentiate. So which page am I on? I think it's 8. Yes, it is 8. Okay, so then y prime will be plus or minus 1 over 2, the square root of 8x squared minus 1, and multiply by 16x. And then y prime will be 16x, so I simplify 8. So plus or minus 8x over the square root of 8x squared minus 1. But this can be replaced by y. It's the same thing. So therefore, it's the same answer. Y prime equals 8x over y. I don't like this. I don't like this notation when I have like this. I prefer dy over dx. It's confusing. I know you sometimes some students prefer that, but it's weird a little bit to have y prime and then y also here. I'm not saying it's not possible. I'm saying it's fine, but I prefer that notation. It's up to you. Next question.
It kept saying it was wrong when I would use y instead of the root 8x squared minus 1. So that's why I was confused.
Yeah, it depends on how they want the answer. You have to read the fine print. I would not ask you to do something like that myself. But is it clear how we get to the answer?
Yeah, that was clear. Thank you.
Okay, perfect. I'm still trying to log in. Yeah, it doesn't even allow me to. It says bad request. I retired this computer last year, but I'm grateful that I have it, because otherwise it would have been a problem today. Good. Next question. Anyone?
I have a question.
Yes. Ready?
It's in web assign 3.7, sorry, 3.9, question 12.
Okay. Is it possible for you to read it? Can you? I can give you permission to share your screen. I'm not able to log in a WebAssign for some reason with this computer. Or just read it to me. Can you read it to me?
Okay, I can read it.
Or if you want to take a picture and text it to me.
Okay.
So it's 240-675-0445. If you want to take a picture, my phone is right here and I can take a look.
I can send it to the Zoom chat.
Oh, okay, fine. Zoom chat is fine. That's even better. Maybe you want to take a screenshot?
Yes, that's a good
Excellent.
Right.
Excellent. Great job. Download. Okay, perfect. It couldn't be better. That's awesome. Okay, let me not speak too soon. Let's see if this computer allows me to do that. Don't laugh. It has Windows 7. You don't even know what that is. You are too young to remember Windows 7. Okay, you said problem 12.
Yes.
A car is traveling north on a straight road at 20 miles per hour. Okay, 20, is it miles? I guess so. So it's traveling north at 20 miles per hour. Is that, or miles, or is it
Because miles should be miles.
meters per second, I think.
Meters.
Is, yes, I see. I can, it's a little blurry. Okay, so it's meters per second. Okay. And uh, and the drone, okay, is flying east at 5 meters per second. Okay, east, 5 meters per second. Okay, perfect. At an elevation of 25 meters. At one instant, the drone passes directly over. Okay, I see. The drone passes directly over the car. Okay, so basically the car is going this way, and the drone is going this way, so north and east. I'm switching it a little bit, but I know what it means. So north and east, and it's above 25 meters. At one instant, the drone passes directly over the car. How fast in meters per second is the distance between the drone and the car changing 7 seconds later? Okay. So we are talking about this distance, but actually, okay. I have to design this in space, in three-dimensional space. So give me 1 second to think how I want to do that. So the situation is something like this. So here's the drone. I just want a tiny drone. Here's my... Okay, so here's the car going north, and here's the drone going east. So at some point in time, I want to determine this distance between the drone and the car. So this will still be a right triangle, and this will still be the height of 25 meters. So I will design, I have to design a trapezoid, a solid. So here's how this works. Okay, this is what I want to present. So here's the drone up here, and here's the 25, and here's the distance. Okay, that's what we want. So this is 25, this is the distance, 25, and this is another right triangle. So there is a right triangle here, and there is a right triangle in space, vertical. Okay, so I don't know if you saw what I was showing. So there is a right triangle in which I have here the drone. Here is 25, and here's the distance. I cannot use the distance because then I have DD, and I can't use that. So that is this triangle. With the 25, the drone is up here, and that is the distance in question. Okay. So what else do I have? I have now on the ground, so this is in space. On the ground, I have this distance. I'm going to call it x. I have this distance y. And this is on the ground where I have, so this piece is this piece. So I'm going to call it A. Is anyone in the clear? This is how I read it. It's very blurry on my computer. So a car is traveling north. It is on a straight road. Okay, so the car is traveling north. So this is the north piece. And the drone is flying east at an elevation of 25 meters. That's it. At one instant, the drone passes directly over the car. Okay, how fast in meters per second is the distance between the drone and the car changing 7 seconds later? Okay. So my first piece, it's an interesting problem. Okay, so first of all, I'm going to look at this triangle in which I have w squared equals 25 squared plus a squared. And again, I'm on page 9.